Hey guys, I'm going to show you how to do the conclusion questions and the graphing for the motion with changing speed. So I just copied and pasted my data table into my own question document just so it was easier to reference. But what you're going to do is you're going to start by making a position versus time graph. And you're going to put the position of the car on the vertical axis, that's right here, it goes on the y-axis, and the time from A to B is going to go on the x-axis. So you're going to go to your create a graph. Make sure you put line and data, you punch all that in, which I've done here already, and you hit preview. And then you're going to say, okay, great, that looks good. You're going to put that into your graph. Sorry, I don't mean graph, I mean your document. So you're going to go ahead and download it or screenshot it, whatever you're going to do, and you're going to go ahead and paste that into your document. And mine's taking a little while to load there, but it's going to go ahead and load into your document. And then you're going to answer these questions on part 3 where it says stop and think. Then you're going to go ahead and make a speed versus time graph. But if you go back to your original group document here, it tells you got to calculate the speeds first because you can't graph the speed if you can't calculate the speed. And you're going to take 1, which is the distance of that little flag there, divided by the time that the car was going through photo gate A or B. So for instance, going back up here, that's not going to want to load, of course. You're going to take 1 to fill in this column, since these are all the same. You're going to take 1 and divide it by 0.0116. And you're going to fill that in for the entire column. Okay, so I took that 1 and divided it by 0.0116. And I put that here, the speed, how fast it was going through photo gate A. So it was going 86.2 centimeters per second through photo gate A. Now you're going to do the same thing. You're going to take 1 and divide it by each of these numbers and put the answer here, where it says speed at photo gate B. Okay, so I did all of the math and I put the speed at photo gate B. And it should make sense that it's going to speed up as that gets farther, as the photo gates go farther and farther away. So now you are going to go ahead and graph it. And that's part 5 here. You're going to make a graph, but this time it's going to be speed versus time graph. So speed of the car at photo gate B is going to go on the y-axis, and the time from photo gate A to B is going to go on the x-axis. Okay, so I plugged in my information here, speed versus time, because again, the time is going to go, time from photo gate A to B is going to go on the x-axis, and the speed at photo gate B is going to go on the y-axis. Okay, and I had to switch some things around here. So again, the time from photo gate A to B should go here on the x-axis. This should always be x and then y. And then the speed at B should go right here on the y-axis. So when you type it all in, you hit preview and you say speed over time, and it should be somewhat of a straight line right there. We're going to go ahead and take that and put it in our document. So I came over to my individual document where it says speed versus time graph and plugged that in. So this is speed over time. Now you're going to answer the stop and think questions. Now make sure when you're looking at it, you're paying attention to which graph. Speed versus time. You know, what shape does it have? And then what's going on for each of these items. And suppose the speed of the car was at 30 centimeters. Sketch how it would look. If you're on a computer and you don't want to sketch it, you can sketch it in drawing or you can describe it. And describe in a sentence how the graph of constant speed looks different from a graph of changing speed. And then use your speed versus time graph to predict how much time the car would have to roll before it reaches a speed of 200 centimeters per second. And you can also use formula if that works for you. And then use your position versus time graph to predict where on the track that would happen. So think about on your position versus time graph. So you're calculating it using this first graph here. And then you're going to go back up here to figure out what time was that at and then what position is that going to be at. And then the very last question, it says to go ahead and set it up and say if your prediction was accurate or not. And if you don't get a chance to do the very last question, then we can do that on Monday and when we get a break back. And that's it.